What happens if we try to forcefully push or pull at the mass spring system at a frequency of our own choosing, like omega, which is different from the natural frequency omega naught of the system? In this case, we'll find that after a while, the mass spring system will oscillate according to our chosen frequency. Let's say the amount of force that we apply is F. Something interesting happens here with the amplitude response of the system, or the amount of displacement in its swings. The amplitude is given by F divided by m times omega naught squared minus omega squared at our forced rate of oscillation omega. The size of the swings back and forth depends on both our chosen forced frequency of oscillation omega and the system's natural frequency of oscillation omega naught. What does this all mean? Well, let's first assume that our chosen frequency of motion, omega, is picked to be very small. In that case, we are slowly moving the system back and forth. In this case, the amplitude of motion, the size of the swings, are mostly determined by the natural frequency, omega naught. And the motion is in sync and in the same direction as we are forcing the system. Instead, if we try to apply a fast oscillation where omega is much larger than omega naught, the amplitude becomes negative. The system is moving in the opposite direction of our actions since the system is too slow to respond to our fast input. Also, the denominator gets so large that the amplitude shrinks down to something very small. So if you try shaking the mass too quickly, you won't see much of anything happen.